So today, the first thing that we will discuss is the ionization energy 1 trend in moving from. This question has come like so many times in paper 2, and there are so many MCQs which keeps coming from here. The first ionization energy trend in moving across a period. So basically we are going to go left to right in period number 3, and we are trying to understand how does the ionization energy values change. We're trying to understand that. Now period number 3, the elements are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. We don't get into argon, but argon also is there obviously. So anyway, so these are the elements of period number 3. These are the atomic number 11, 12, 13, 14, 15, 16 and 17 and 18. Remember, we are going left to right across a period. And we are trying to understand how does the ionization energy change and why does it change. So this is very, very important discussion. It keeps coming so much in the examination. Okay, I really hope that you have your notes and everything is getting copied in your notebook as usual. Particularly those kids who are taking the Zoom online class first time with me. Please, I insist that everything goes in the notebook as usual. Now let's have a look at the syllabus. Let's have a look at the ionization energy values. Okay. Earlier the data booklet was given, but now the data booklet is not given, so you're kind of expected to know the graph. But don't worry, I will tell you how to learn the graph very quickly. So let's have a look at the first ionization energy values from sodium to argon. Okay, so let's have a look. Sodium to argon. So basically from here, sodium 494 and then magnesium, aluminium. Can you see the numbers clearly? Give me yes or no. Why for yes? Okay, now I want you to look at sodium's first ionization 494. So sodium is 494. I'm just writing the numbers here for your reference. And magnesium is 736. Magnesium is 736. Aluminium is 577. 577. Silicon 786. Phosphorus and sulfur. Phosphorus is 1000. Sulfur is 1060. Chlorine 1260 and 1520. So 1260 and 1520. These are the first ionization energy values. Right. So now what we have to do, I want you to make a sketch of it, because you will be asked sometime to draw the sketch and they will ask you to explain why is this happening. So this is the ionization energy 1 and these are the period 3 elements, and we are trying to find out what is the trend. Now I'm giving you a start. If sodium is 494, so let's say I'm making sodium here. Now you notice that the ionization for magnesium is higher than sodium. It is 736. So I'm putting a dot here. This is for magnesium. So if you want, I can write the numbers here. 494, 736. Now notice aluminium is 577. It is less than 736, but it is more than 494. It is slightly going down. It's slightly going down here. This is aluminium. with 577. Silicon is 786. It's gone up a bit more. So I'm going up here. This is 786 for silicon. Hi Yakin, can you hear my voice? Just say yes in the Zoom chat. Just keep all your mics off. Okay, great. Yakin, this is the first slide. I have not started the main explanation. So we are just trying to understand ionization energy trend when we go from left to right in a period. I'm discussing period number 3 from sodium to argon. These are all the ionization energy values. We are trying to understand why the graph is like that. After silicon, I see phosphorus is 1000, which means I'm still going up. So I'm just putting the number here. This is phosphorus. After phosphorus, sulfur. Okay, I think the numbers are wrong. Phosphorus is 1060. Yep, we made a small mistake. Phosphorus is 1060. Sulfur is 1000. Guys, can you please check? Sulfur is 1000. So if sulfur is 1000 and phosphorus is 1060, which means we are coming slightly down here. This is 1000. This is for sulfur, slightly less. After sulfur, chlorine is 1260. It's actually a bit more. So we are going up again. This is the 1260. This is phosphorus. And then we go all the way to 1520, which is still going up. So that's a 1520, which is argon. Now, this is the ionization energy trend in period 3 elements. Do you notice a staircase kind of a diagram? Generally, what do you notice? What is happening? Is the ionization increasing or decreasing? IN for increasing, DE for decreasing. What do you think? Generally, what do you think is happening to ionization when we go left to right? Generally, increasing, correct? Generally is increasing. So here's the start point. Ionization energy generally increases going from left to right in a period. Okay, now you have to tell me the reasons. Remember, this is a very repeated examination area. You will get so many questions from this. Okay, now tell me, why do you think this is happening? Now, do you remember the factors affecting ionization? What are the factors I taught you last week? I taught you size, number of protons, shielding effect, and spin pair repulsion, correct? Now, tell me about the size of atoms. What do you think happens to size of atoms? Very good, sir. What happens to size of atoms when you go left to right? Should it increase or decrease? You can use short form. Increase or decrease size of atom. Now remember, I gave you a graph. I gave you a graph which helps you to learn what happens to size of atoms when we go left to right. Size of atoms, if you remember, it decreases from left to right. Very good. In case anyone wants little help, you might remember I gave you a graph like this. Do you remember I gave you a graph? Sodium was here and chlorine was here. Size decreases when you go from left to right. So we did this before. So if the size decreases, do you think ionization should be more? Yes or no? If the size becomes less, should the ionization be more? It is. Look at your notes. If the size becomes more, ionization energy becomes more. So it is a correct statement. I can write this in the exam. What about the number of protons? What happens to number of protons or nuclear charge? What do you think happens? Should it increase or should it decrease? Number of proton is also called as the nuclear charge. So when you go left to right, you see the atomic number 11, 12, 13, 14, 15, 16, 17, 18. So the number of proton is increasing. So since the number of proton is increasing, number of proton, which is also nuclear charge, is increases. So because this happens, so what happens to the nuclear attraction on the valence electron? What happens to nuclear attraction? So nuclear attraction on valence electrons, you know what is valence electrons? Electrons in the last shell. Valence electron increases. Now, does these 2 points make sense so far? Size of the atom decreases left to right. Number of proton also becomes more left to right. So because of all this, nuclear attraction is becoming. Makes sense? What about the shielding effect? What do you think happens to shielding effect? Do you think it remains the same? Do you think it increases? Do you think it decreases? Shielding effect is based on the number of shells and subshells. Don't forget, you are in the same period number 3, which means when you go left to right, the number of shells are not changing. So I hope you realize it, that the shielding effect remains fairly constant. We use the word fairly constant. If the shielding effect, if the number of shells changes, then the shielding effect will change, correct? So it is fairly constant. When I use the word fairly constant, that is because if you remember the magnesium and aluminium case, if you remember, check your notes, question number 2, you will find I said aluminium has more shielding effect than magnesium. But apart from that, nobody else has that situation. Everyone has the same number of subshells, so they all have the same shielding effect. Okay, this question so many times in paper 1, paper 2. So are you clear as to what happens to ionization left to right and why does it happen? So what happens to ionization? It increases. Why does it happen? Because atomic size is becoming less, number of proton is becoming more, shielding effect is not changing. So because of all this, the nuclear attraction is increasing on the valence electrons. Okay, on a scale of 1 to 10, tell me how clear you are. 10 understood everything, 1 you don't know what I'm talking. Everyone please. And if anyone has given a lower number, please open the mic and talk to me. Tell me what's bothering you. A 10.3, thank you.